Oh, hi guys, this is Mr. Urrego. Welcome back to our series Beat the Test, the review for our geometry and of course exam. Okay, so let's tackle question number 24. Let's read it. It's a word problem, so let's read it first. A school, hospital, and supermarket are located at the vertices of a right triangle. Okay, so I have a right triangle here and I'm locating the school, hospital, and supermarket. Let's read. So I make it right triangle. That's the first thing I have to do. Of a right triangle formed by three highways. So the three sides of the triangle are the highways. Okay, next. Let's make it ready. Yes, okay. The school and hospital are 14.7 miles apart. School and hospital are separated 14.7 miles apart. So this diagonal, which is the hypotenuse for my big triangle, is 14.7 miles. The distance between the school and the supermarket is 8.82. Between the school and the supermarket is 8.82. The distance between the hospital and the supermarket is 11.76. Hospital and supermarket is 11.76. So the bottom of my triangle is 11.76, the left side is 8.82, the hypotenuse is 14.7. Let's read the question. A service road will be constructed from the main entrance of the supermarket, to the highway that connects the school and the hospital. So it will go from the supermarket to the highway that connects the school and the hospital. All right, so I'm looking for this. What is the shortest possible length for the service road? Round answer to nearest 10. So guys, we're looking for this service road. So I drew that line. But that line could be also from here to here, or from here to here. Okay, out of those three lines, which one is the shortest? Yes, that's right, the first one. Okay, so let me talk about that. So the shortest segment, the shortest line, okay, from a point to a line is the perpendicular line. So that line is called an altitude. That's the shortest segment. Straight line is a perpendicular line. So this is altitude to the hypotenuse. So that's the shortest. Okay. All right. So how do we find that answer? How do we find this length? So let me call that length I'm going to look for X. That's my shortest road. Okay. We have the school, supermarket, and hospital. What's happening is the following. So guys, that altitude, there's a property about that altitude. That altitude is dividing my big triangle in three triangles. The one on the left, the one on the bottom, bottom right, and the big triangle. So I'm going to call this triangle 1, triangle 2, and the big triangle. Okay, so to find this distance, there's no like one-step process to do it. Unfortunately, there's nothing like that. So I only have the length of the triangle, the big triangle, but I also need some of the length of the shortest triangle. So from the short triangle, I have this 1176. I know that. I have from the little triangle, I have 8.82. I know that. Okay, that's 0.82. But I also need this on the top and this on the top in order for me to find the value of X. Okay, so the first thing that I'm going to do is I'm going to find one of those distances. So this little piece on the top, let me call that Y, for example. So this Y is going to be here. So this Y is on the top. So I need to find that length. Okay, so let's start with that. All right, so what's going to happen is I'm going to relate this little triangle with the big triangle. Okay, so let's do that. Now I'm gonna let me write this in. Let me see. I have this. All right, cool. So remember, this is a 90 degrees. So this little triangle is a right triangle. This is a right triangle. The big triangle is a right triangle. So before we move on, I need to in order for you to understand better, I need to relate this with angles. So let's pretend. I'm gonna get the big triangle. Okay, I'm making the big triangle. It's a 90-degree angle. Let's pretend that this angle, let's call that 40 degrees. Okay, and if this is 40, then the angle on the top has to be 50, because the sum of those two acute angles has to be equal to 90, because remember, 90 is on the bottom, the sum of the three equals 180. Again, if one angle is 40, then the other acute angle is 50, and this box is 90. Why? Because 90 plus 50 plus 40 is 180, so the sum of the three equals 180. So every time I have a right angle, the other two has to be equal to 90. Alright, so this is the big triangle. So let's go. This corner, let me translate this corner here. So this corner is 50. Therefore, this corner is 50. Okay. Now, if this corner is 50, this on the bottom, let's put two little marks, that's going to give me 40 degrees. Therefore, this one is 40 degrees. Alright, here we go, let's finish. So if this is 40 and that's 90, then this over here is 50 degrees. Alright, same idea. In the little triangle, if this corner is 50, because it came from the big triangle, 50, 50, 50, and this one is 90, then the bottom has to be 40 degrees. Okay, the only reason I'm giving you those angles is so you can have an order on the size of the triangle. So let me compare the little triangle with the big triangle. So the big triangle is 1176. Here is going to be 8.82. Oh my God, horrible. And the hypotenuse is 14.7. Let me relate the little triangle with the big triangle. Okay, so again, I want to find the value of y. So in my little triangle, I want to relate something that I don't know with this side that I know. So my first proportion is going to be like this. Y over, by the way, remember I said these triangles are similar to each other and similar to the big triangle. Why? Because I have two angles that are equal, the 40 and 50 in this case. The 40, look at the 40, the 50, the 40, the 50. Let's pretend that these are the right answers, but any two angles that I have here, they will be the same on the little triangle and they will be the same on the big triangle. So those three triangles are similar by angle. Therefore, they're proportional. The sides are proportional, and that's what I want to write. I want to write a proportionality statement, not a proportionality statement, segments that are proportional to each other. So let's do it. Little triangle. I'm going to put little here. Little. And then I'm going to put big in the other side. So the left side is going to be my little triangle. The right side is going to be my big triangle. On the little triangle, I want to do y over 8.82. And you're going to get this right away. So the little triangle, I'm relating the side that goes from 50 to 90 degrees. So on the big triangle, I need to relate the side that goes from 50 to 90. Again, the y goes from 50 to 90 degrees, right? In the big triangle, from 50 to 90 degrees, I have 8.82. The little triangle, underneath I have 882. 882 on the little triangle goes from 50 to 40. That's 8.82. On the big triangle, 50 to 40, I have 14.7, which is my hypotenuse. Again, the little triangle, 8.82 is my hypotenuse across the 90. Therefore, I got to write my hypotenuse on the big one. So this is the proportion. Now I got to solve for y. That's how you relate the size of a triangle, and that's when I'm using the angles. So now how can I use for y? How can I solve for y? I'm going to do cross multiplication. So 14.7 times y equals the other diagonal, which is 8.82 times 8.82. Okay. Now, I don't want to solve this right now, so I want to find the value of y. Let's leave the y by itself. I got to cancel the 14.7, so I divide both sides by 14.7. And now the 14.7 divided by 14.7, that's canceled. And y equals this. Now I'm going to put this in the calculator. which is 8.82 times 8.82 divided by 14.7. If I multiply 8.82 times 8.82 divided by 14.7, my y is going to give me 5.292. I'm going to keep the 3 decimal places. Alright, miles. So this is the y value. So this is this little piece. Okay, now I have this. Alright, now what I want to do is I'm going to find the other piece. Okay, so let me erase and let's make a triangle, and I'll be back in 1 second. Okay, I made a couple of changes. I got rid of the text so I have more space. So I'm just going back. Okay, so we found the value of y, alright, which is this piece. I make the 2 little triangles on the top, so this value of y is going to be 5.292, alright? I'm keeping 3 decimal places to make it as accurate as possible. And I have this top, and I have the side. Alright, from the little triangle I have 11.76, but I don't have the length of here. Okay, but keep in mind, the big triangle, the whole thing is 14.7. And if this is y, then the rest is 14.7 minus whatever is y. Okay, so this side is 14.7 minus 5.92. So this remaining is 5. Okay, is the whole thing 14.7 minus y. Therefore, 14.7 minus 5.92, that's going to give me, where is it? 9.408. So this piece is 9.408. Look, if this is 592, then the remaining is 9.408. Okay, so now I have those 2 pieces. Now I can find the value of x. Remember, all this is because I want to find the value of x, this diagonal. And this diagonal is this piece, which is also this piece. Okay, so I have the top, I have the left side, I have the bottom side. Now let's relate those. Okay, so my last proportion is something that is called the geometric mean. Okay, how is the geometric mean? So on this big triangle, guys, the geometric mean is this position on a proportion. If you notice, I have a proportion here. When I'm doing the geometric mean, it's a proportion. It's this diagonal. These 2 spots are going to be the value of x. What's the value of x? My altitude. The value from my vertex to my hypotenuse. That's my geometric mean, which in this case is x and x. What goes on the other 2 spots? The other 2 spots are these 2 pieces. The value of y, which is 5.92. Okay, that's a 5. And again, my geometric mean in these 2 spots, and the 2 empty ones is the value of y and the other piece, the 2 pieces for my hypotenuse, which is 5.292 and 9.408. From here, I'm going to solve using the cross multiplication. X times x is going to give me x times x, and that's equal to the other diagonal, which is 4.92 for 5.292 times 9.408. Okay, x times x is going to give me x squared, and this is going to give me 49.787. The last step is to get square root. Remember, I'm looking for the value of x, so square root of square root. X is going to give me 7.056. But my problem was rounded to nearest tenth. I checked the next decimal. Because the next decimal is 5 or higher, then the value, the previous value, goes up 1. So my final answer is 7.1 miles. Alright, so all of that to end up in the geometric mean. Geometric mean is the altitude from the vertex to the hypotenuse. Alright guys, again, you learned something, please like the video and subscribe to the channel. That helps a lot. Stay tuned for the next videos. Thanks a lot for watching. Bye-bye.